Hello everyone, welcome to Brain Blitz Audios. In this episode of Cbse board exam, we'll be looking at previous year questions of mathematics from Cbse board exams. The chapter we're dealing with is the 6th chapter of grade 12, Application of Derivatives. Let's look at our first question. A window is of the form of a semicircle with a rectangle on its diameter. The total perimeter of the window is 10 meters. Find the dimensions of the window to admit maximum light through the whole opening. So let's look at this question. So firstly, let's draw the diagram of the question. So it consists of a rectangle topped by a semicircle. So now we'll consider 2x as the breadth of the rectangle, 2y as the height of the rectangle. So this will be 2x, this will be 2y. And we'll consider P as the perimeter of the window and A as the area of the window. Now, in the question, it's given that the perimeter of the window is 10 meters. So that means that the three sides of the rectangle, 2y, 2x, and 2y, plus the length of the semicircular portion will contribute to the perimeter. And so let's write them down. So the perimeter is 2y plus 2x plus 2y plus the length of the curve is given as 2 pi r divided by 2, which becomes pi r. So there, and since the perimeter is given as 10, that implies that 2x plus 4y plus pi x, over here the r is equal to x, will be equal to 10 centimeters. Now, we need to find the area of the window. So the formula for area is area of the rectangle ABCD plus the area of the semicircle, which will be equal to length into breadth in the case of the rectangle plus pi r square by 2 in case of the semicircle. So our area will be equal to 4xy plus pi x squared by 2. So therefore, it's convenient that we try to replace y here. So from this equation, 2x plus 4y plus pi x is equal to 10 centimeters, we'll get y as 10 minus pi x minus 2x divided by 4. Let's put it in our equation for area. So that's A is equal to 4x times 10 minus pi x minus 2x divided by 4 plus pi x squared by 2. So therefore, the 4 and the 4 gets cancelled. and the x is multiplied to the bracket, so we'll get 10x minus pi x squared minus 2x squared plus pi x squared by 2. And on further simplifying, we'll get 10x minus 2x squared minus pi x squared by 2. This is the formula for the area of the window. Now what we do is we do the second derivative test here. So for that, we'll find the first derivative. So that is dA by dx. So we differentiate with respect to x. So dA by dx will be equal to 10 minus 4 into x minus 2 pi x by 2. So the 2 and the 2 gets cancelled, so we'll get 10 minus 4 minus pi x. Now, what do we do here? For maxima and minima, we will take dA by dx as 0. So what we'll get is 10 minus 4x minus pi x squared by 2 is equal to 0. So 10 will be equal to 4x plus pi x squared it's not x squared, it's just pi x, because after derivative we get pi x, so it's 10 minus 4x minus pi x. So 10 is equal to 4x plus pi x. So we'll take x common, and so finally we get x as 10 divided by pi plus 4. So that is that step done. The next thing we do is take the second derivative. So that is d squared a by dx squared. So that will be equal to d by dx of 10 minus 4x minus pi x. And so derivative of x is 1. So that leaves us with minus 4 and minus pi. 10 has no x, so it just vanishes to become 0. So what we get is minus 4 minus pi. And so this value is less than 0. So d squared a by dx squared, given that x is equal to 10 by pi plus 4, whether we put the value of x or not, it's still going to be minus 4 minus pi. So that is less than 0. So when that is less than 0, we have the maximum area of window at x is equal to 10 by pi plus 4. So now let's look at the equation. Y is equal to 10 minus pi x minus 2x divided by 4. So now we'll put value of x. So the value of x is 10 by pi plus 4, so we'll put that. So 10 minus 10 pi by pi plus 4 minus 20 by pi plus 4, the whole divided by 4. Now let's take pi plus 4 common. And so what we'll get is 40 plus 10 pi, that is after multiplying 10 with pi plus 4, minus 10 pi minus 20. So 10 pi and 10 pi gets cancelled. 40 minus 20 is 20, and divided by the 4 comes in here, so it becomes 4 into pi plus 4. So y is equal to 20 by 4 plus 4 into pi plus 4. 20 goes into 4 5 times, so y is equal to 5 by pi plus 4. So x is equal to 10 by pi plus 4. So 2x is equal to 20 by pi plus 4. And since y is equal to 5 by pi plus 4, that implies that 2y is equal to 10 by pi plus 4. So what this means is that maximum light comes through the window of dimensions 2x is equal to 20 by pi plus 4 and 2y is equal to 10 by pi plus 4. So this is our answer. Now let's move on to the next question. Show that the altitude of the right circular cone of maximum volume that can be inscribed in a sphere of radius r is 4r by 3. Also show that the maximum volume of the cone is 8 by 27 of the volume of the sphere. So first things first, let's draw the diagram. So we'll have a sphere. And then I'll try my best to draw a cone. Okay, so we have something that resembles a cone here. We'll mark it as A, B, C. And then this length AB is capital R. And then we have a point O here, which when joined with B gives small r. And so let's consider capital R as the radius of cone. And let's take the distance AC as h, and that is the height of the cone. And let small r be the radius of the sphere. So now, what do we do next? So what we do now is in triangle OAB, we apply the Pythagoras theorem. So r square is equal to capital R square plus OA square. So what is OA? So we have OA as h minus r. So therefore, small r square is capital R square plus h minus r the whole square. So this is by Pythagoras theorem. And so we'll expand h minus r the whole square. So small r square is equal to capital R square plus h square plus small r square minus 2 small r h. R square gets cancelled. And so we'll write capital R square as 2RH minus h square. Now, let's consider the volume of the sphere by using the formula 4 by 3 pi r cubed. This is the volume of the sphere. Now let's look at the volume of the cone. Now that will be equal to 1 by 3 pi r square h. Capital R is the radius of the cone. And so here we'll insert the value of r square. So this will be 1 by 3 pi to RH minus h square. So this is the volume V. Now, using the second derivative test. So first things first, we differentiate it with respect to r. No, actually, we differentiate it with respect to h. Since we have to find the altitude, we need to differentiate it with h. So on differentiating with respect to h. So dv by dh will be equal to 1 by 3 pi. And then 2r's. So this becomes 4h minus 3h square. So now what we do is for maxima and minima, we take dv by dh as 0. So 1 by 3 pi into 4h minus 3h square is equal to 0. So in the end, we'll get 4r is equal to 3h, and therefore h is equal to 4r by 3. Now we'll do the second derivative. D square v by d h square will be equal to 1 by 3 pi into 4r minus 6h. So now we'll put the value of h here. So d square v by dh square at h is equal to 4r by 3. So that'll be 1 by 3 pi into 4r minus 6 into 4r by 3. So 3 goes into 6 2 times. So that will be equal to 1 by 3 pi into 4r minus 8r which is equal to minus 4 by 3 pi r. Now this is less than 0. So what we can write is that the volume is maximum at h is equal to 4r by 3. Now let's go back to the original equation for volume. Volume is 1 by 3 pi into 2r, 4r by 3, the whole square, minus 4r by 3, the whole cube. So that'll be equal to 1 by 3 pi, and then in the brackets, so 4r the whole square will be 16r divided by 3 square is 9, minus 4r the whole cube is 64r cube divided by 3 cube is 27. So we'll get 1 by 3 pi, and then inside bracket 32r by 9 minus 32r squared by 9 minus 64r cube divided by 27. And so we will get 1 by 3 pi r cube into 32 by 27. So now what we do is we take 8 by 27 out. So 8 by 27, big bracket. So 8 is taken out of 32, so what remains is 4. 4, and then we divide it by 3, and then pi r cube. And so this is the volume of the sphere. So we were asked to prove that the maximum volume of the cone is 8 by 27 of the volume of the sphere. So we get that the maximum volume of the cone at h is equal to 4r by 3 is 8 by 27 of the volume of the sphere. So that is how we got this answer. Now let's look at the next question. Show that the semi-vertical angle of a cone of maximum volume and given slant height is cos inverse 1 by root 3. Now let's draw our figure first. So we have a cone here. Okay, so this is the semi-vertical angle. This is its height. This is its slant height, L. And we take this as R, the radius. And we'll mark it as ABC. So let R be the radius, L be the slant height, and H be the height of the cone. So how do we proceed in this question? Since we have an angle theta, let's convert R and H in terms of theta. So in triangle ABC of the figure, so theta is angle A. So we can write sine theta as opposite, which is R, divided by hypotenuse, which is L. So that means R is equal to L sine theta. Similarly, cos theta will be equal to H by L, meaning that H is equal to L cos theta. Now, The volume of a cone is 1 by 3 pi r square h. Let's put the values of r and h. So that is 1 by 3 pi into L square sine square theta, because it's r square, into L cos theta, which will be equal, so that means volume will be equal to 1 by 3 pi, L square into L is L cube, into sine square theta cos theta. Now, on differentiating with theta, we'll get dv by d theta as 1 by 3 pi L cube, and then we open the bracket. So over here, we use the product rule in differentiation. So sine square theta into d by dx of cos theta, which is minus sine theta, plus cos theta into d by dx of sine square theta. So that is to sine theta times d by d theta of sine theta, which is cos theta. So that is our differentiation. On simplifying, we'll get 1 by 3 pi L cube. Then in the bracket, minus sine theta into sine square theta gives minus sine cube theta. Plus cos theta into 2 sine theta cos theta gives 2 sine theta cos square theta. The next step is for maxima and minima, dv by d theta is equal to 0. So that means 1 by 3 pi L cube minus sine cube theta plus 2 sine theta cos square theta is equal to 0. Now we can take 1 by 3 pi L cube to the right hand side and it will still be 0. So that means minus sine cube theta plus 2 sine theta cos square theta will be equal to 0. And we'll take sine cube theta to the other side, so we'll get sine cube theta is equal to 2 sine theta cos square theta. And so we can cancel a sine theta from here, and so the 3 becomes a 2. So we'll get sine square theta is equal to 2 cos square theta. Now what do? Is we divide by cos square theta. So that will give us tan square theta is equal to 2. And on taking the square root, we'll get tan theta is equal to root 2. Therefore, theta is equal to tan inverse of root 2. So we found our theta. Now, what we do next is double differentiation. So d square v by d theta square will be equal to 1 by 3 pi L cube times the differentiation of whatever is in the bracket. So minus sine cube theta. So that is minus of 3 sine square theta, because d by dx of x cube is 3x square, times d by d theta of sine theta, so that is cos theta, plus 2 sine theta cos square theta will turn into 2 cos theta times cos theta, so cos theta times cos square theta by using the product rule, and then minus 4 sine square theta cos theta. And so now what we'll get is 1 by 3 pi L cube, and on simplification in the bracket, we'll get 2 cos cube theta minus 7 sine square theta cos theta. Now recall that sine square theta is 2 cos square theta. So we can put that value over here. So we'll get d square v by d theta square is equal to 1 by 3 pi L cube times 2 cos cube theta minus 14 cos cube theta. That is equal to 1 by 3 pi L cube times minus 12 cos cube theta. So then what we'll do is we'll divide 12 by 3, so we'll get 4. So it will be minus 4 cos cube theta times pi L cube. Which is greater, actually lesser than 0. So d square v by d theta square at theta is equal to tan inverse root 2 is less than 0. So that means volume is maximum at theta is equal to tan inverse root 2. Now, in order to find the given slant height, so what we do here is we know that tan theta is equal to root 2. And we also know that theta is the semi-vertical angle. So therefore, in this triangle, what we get is that root 2 will be the adjacent side and 1 will be the opposite side. So since adjacent by opposite, we know actually it's root 2 in the opposite side, 1 on the adjacent side, because tan theta is sine theta by cos theta. So that is opposite by adjacent. So opposite is root 2, adjacent is 1. Root 2 by 1 is equal to root 2, which is equal to tan theta. So over here, using Pythagoras theorem, we get root 2 the whole square plus 1 the whole square. So mind you that 1 is here and root 2 is here. The whole root is equal to root 3. So the value of the hypotenuse is root 3. Now, we'll get cos theta as 1 by root 3. And so L, which is given as cos inverse of 1 by root 3. So that gives us our answer. Now let's go to the next question. Okay, so now let's look at our next question. Show that a cylinder of given volume open at the top has minimum total surface area when its height is equal to the radius of its base. Let's look at this question. So our figure here, let's draw it a bit better. Yeah, so this should do it. So our cylinder is open at the top. It's kind of like a glass. So it has curved surface area and a bottom surface. So let R be the radius, H be the height, V be the volume, and S be the total surface area of the cylinder open at the top. Now we'll write the volume of the cylinder as pi r square h in accordance with the formula. And S, since it's an open cylinder at one end, it will be equal to 2 pi r h plus pi r square. And so over here, it's best if we replace h. So h will be equal to v by pi r square. So S will be equal to 2 pi r times v by pi r square plus pi r square. So pi gets cancelled. One of the r's gets cancelled. So S is equal to 2v by r plus pi r square. That's the formula for the surface area. Now on differentiating with r, we will get ds by dr will be equal to minus 2v by r square plus 2 pi r. So we had 2v by r. So when d by dx of 1 by r is present, that term will change into minus 1 by r square. So minus 1 by r square times 2v is minus 2v by r square. And d by dx of r square is 2r, which on multiplying with pi, we get 2 pi r, our second term. Now, for maxima and minima, ds by dr is equal to 0. So that means minus 2v by r square plus 2 pi r is equal to 0, which means 2v by r square is equal to 2 pi r. And on putting the value of volume as pi r square h, so we'll get 2 pi r square h divided by r square is equal to 2 pi r. So r square gets cancelled on the numerator and the denominator. 2 pi and 2 pi gets cancelled on both sides. So we get the value of r as h. So the radius of the cylinder is equal to the height of the cylinder. Now, the second differentiation, ds square by dr, which is equal to d by dr of minus 2v by r square plus 2 pi r. Now, d by dx of 1 by r square will be equal to minus 2 by r raised to 3. So minus 2 by r raised to 3 times minus 2v will be equal to 4v by r cubed plus d by dr of r is 1, so that will be 2 pi. So 4v by r cubed plus 2 pi. Now we'll put the value of r. So d square s divided by dr square at r is equal to h is equal to 4v by h plus 2 pi. Now this is greater than 0 because h is greater than 0. So therefore, our surface area is minimum when h is equal to r. And that is our answer. So we were asked to find that a cylinder open at the top of a given volume had minimum total surface area when height was equal to the radius. So we first proved that the height was equal to the radius, and then we've proved that S is minimum. So that is the end of the question. The last question. A wire of length 28 meters is to be cut into two pieces. One of the pieces is to be made into a square and the other into a circle. What should be the length of the two pieces so that the combined area of the square and the circle is minimum? Okay, so let's start with this question. So we have a wire of 28 meters that is converted into a square and a circle. So let x be the side of the square and r be the radius. of the circle. Now, according to our question, the length of the wire is equal to perimeter of square plus perimeter of the circle. Now, the perimeter can also be known as circumference for a circle, and that is equal to 28 meters. So therefore, 4 times x, which is the perimeter, plus 2 pi r, which is the circumference, will be equal to 28. On dividing by 2, we'll get 2x plus pi r is equal to 14. And so now we need to find out the combined area, which is represented as A. This will be area of square plus area of circle. That will be equal to pi r square plus x square. Pi r square is area of the circle, x square is area of the square. So it makes sense that we find the value of x square here. So 2x plus pi r is 14. So therefore, x is equal to 14 minus pi r divided by 2. Therefore, we get the value of the area as pi r square plus 14 minus pi r by 2, the whole squared. Now, on differentiation with r, so we get dA by dr is equal to, the differential of pi r square is 2 pi r, and the differential of 14 minus pi r by 2, the whole square, will be done by the box method. So 2 times 14 minus pi r by 2, the whole raised to 1, times the differential of pi r by 2, minus pi r by 2. So that will be minus pi by 2 times 1. So what we get is 2 pi r, and then this 2 gets cancelled. 2 pi r minus of 14 into pi minus pi square r divided by 2. This is dA by dr. Now, for maxima and minima, dA by dr is equal to 0. So 2 pi r minus 14 pi minus pi square r divided by 2, which is in a bracket, will be equal to 0. So 2 pi r will be equal to 14 pi minus pi square r divided by 2. Let's take 2 to the other side because it can be cancelled. So 4 pi r will be equal to 14 pi minus pi square r. Let's take pi common, so that'll be 14 minus pi r. We'll take pi and pi cancellation, so what we get is 4r plus pi r is equal to 14. And so what we do is r is equal to 14 divided by pi plus 4. So the radius is 14 by pi plus 4. Now we'll do double differentiation. D square A by dr square will be equal to d by dr of 2 pi r minus 14 minus pi square r divided by 2 So d by dr of r is 1, so we get 2 pi. And then plus pi squared by 2. Because what happens here is that 14 has no term of r, so it becomes 0 on differentiation. And minus pi square r by 2 becomes minus pi squared by 2. Minus of minus pi squared by 2 is pi squared by 2, so 2 pi plus pi squared by 2. And so we can write that d square a by dr square at any value of r, and since the value of r here is 14 by pi plus 4, we write that will be equal to 2 pi plus pi squared by 2, which is greater than 0. So the area is minimum at r equals 14 by pi plus 4. So now let's take the formula for x, which is 14 minus pi r by 2. Let's put the value of r here. So that's 14 minus pi into 14 by pi plus 4 divided by 2. So now that becomes 14 pi plus 56 minus 14 pi divided by 2 times pi plus 4. So therefore we get 56 by 2 times pi plus 4. So therefore x is equal to 28 by pi plus 4. So the value of the side of the square is 28 by pi plus 4. So the length of the side of square is 28 by pi plus 4, and the radius of circle is 14 by pi plus 4 when a is minimum. So we were asked to find the length, and so we found that the length side of the square is 28 by pi plus 4, and the radius of circle is 14 by pi plus 4. So that is our final answer. So that concludes this video of Cbse board exams. We hope that you enjoyed this video and found it informative. For more of our useful content, please subscribe to our channel, Brain Blitz Audios. We'll be back with more useful and interesting content, such as mind maps, solutions of Cbse board exam questions, NEET preparation, learner words, etc. Until then, stay safe, stay healthy. Ta-ta for now.